Hi Apes, this is Chapter 4, Part 3. We're going to talk about aquatic biomes in this section. So these are characterized by how much salt they have in the water, the depth of the water, and how much water, if and where, and how much the water's flowing. So those three things determine what a biome is in the water world. So streams, rivers, creeks, all those things are flowing water, and they originate from underground springs or runoff from rain or melting snow. So our Marsh Creek runoff, our Marsh Creek itself is starting at the top of is near the top of Mount Diablo, and that's runoff from Mount Diablo. So that's an example of a creek. They're narrow, they carry small amounts of water, and they join to rivers like Marsh Creek joins to the Sacramento River. Lakes and ponds are standing water, they don't move, and we don't have a lot of vegetation going through from them, maybe just on the edges. Ponds are small, lakes are bigger. So here's some examples of lakes and ponds. If you look at this example right here, we've got the littoral zone, and that's where you see some plants growing through. You'll have cattails and things like that growing on the edges, and you have photosynthesis happening in this area. Then you have the limnetic zone right here, and you can't have rooted plants, but you can have algae, and that's called phytoplankton. Next you have the profundal zone. It's below the limnetic zone, and sunlight can't get down here, so you don't have any producers down there. Nutrients are recycled in the food web from this area. Okay, you do have bacteria down here breaking down everything that's has died from this zone. So you can have the plankton, the phytoplankton up here, algae, and other little animals living off of that, and the fish. And when they die, then they're going to drop down to this zone, and all those nutrients are going to be recycled by decomposers down there. They're going to be using up oxygen down here, so this area doesn't have very much oxygen because all those little recycler dudes are using up oxygen down there. Okay, the very, very bottom where you have the mud is called the benthic zone. So those are the parts of a lake or pond. So again, littoral zone, you have plants growing. You're also going to have algae. Limnetic is the open water, and you have phytoplankton there. And this extends to where the sunlight can't penetrate anymore. The profundal zone, you don't have sunlight, and you don't have producers. Benthic is the bottom where you have all the muddy part. Wetlands are extremely important to the earth. They're the filters, the sponges of the earth, where a lot of chemicals that we don't want in our ecosystem are sequestered. They're like the cattails and all the algae and all the little plants are going to take up things that we don't want to be running off from our rivers and our creeks. So wetlands are extremely important. They're also important because they are habitats for migrating birds. They're nurseries for birds and for fish. So they're extremely diverse, have an extremely important reason to be in our ecosystems. We need them desperately, and humans have been reducing them to very, very small amounts. We didn't know the purpose of wetlands before, like in the early 1900s, but now we're starting to realize that they are very, very important to us. So pretty pictures. Salt marshes are at the edge of where creeks they're next to the ocean. They're where rivers come and meet into the ocean. For example, the Everglades and things like that. Very, very important to us. They have some non-woody emergent vegetation, cattails and things like that growing. Very, very, very productive biome in the world, so we need to understand salt marshes. There's tons of different things that live there, and plants as well. So, extremely productive part of the world. We don't want to mess with them. Mangrove swamps are made by mangrove trees. They have really cool roots that are all tons of roots off of the bottom of the plant and off of the bottom of the tree, and you can see them. And they hold in soil really well. So they're really, really important in places like Florida and other places where you have tornadoes and tropical storms, because they're going to hold all the soil in on the edge of the land. Very, very important. They're salt tolerant and they protect us from all kinds of stuff. Very important. Pretty example. See all the cool roots there. Intertidal zones are when you go to the ocean, you go to the beach, you go hang out there, and you see that the water comes up at high tide and then recedes at low tide, and all the little plants that live in that between low and high tide, you see the little wetland pools, the little pools there, and those guys are super cool, and they have to live in really, really challenging environments because half of their day is wet time and half of their day is dry time, and plus they have the surf pounding on top of them. So they're very cool animals that have to live in the little tide pools there. So you got sea stars, you got chitin, you got little hermit crabs and things like that, and all the little turban shell guys. It's an amazing little place. Plus the weird kelp that lives there. It's pretty cool. Coral reefs are also very, very productive areas. They have lots of things that live there. They have a really diverse marine biome. Tons of things live there. So the basis of the coral reef is the little coral animal that lives inside the coral tubes that they make, and they live symbiotically with the algae that are there. And they get both of them live off each other, so it's very important. What's happening now is there's a lot of worry about this thing called coral bleaching. It's when the algae dies. We're not sure if it's because of global warming, disease, or some other environmental change that's happening to them. But we really, really need to protect the coral reefs. They're very diverse and they give areas for a lot of different animals to live. Pretty coral reefs. We love the coral reefs. Open ocean has different zones to it. It depends on the depth of light that goes in there. So wherever light can happen, you can have your phytoplankton and algae growing. Photic zone. Photic means light, so that's where you have photosynthesis. Aphotic is where you do not have light. A means not, so no light being seen there, or very little light. Some plants and animals, some animals, can live without using oxygen, so they can use sulfur and they can use methane to generate their energy. So this happens deep in the ocean. The chemosynthesis happens way deep in there, and that's just been a recent finding that we figured out about all these guys down there. So that's the end of that chapter. Oh, hold on. Make sure I got through everything. Clicked on the wrong thing. Sorry, guys. Talked about coral reefs. We saw a beautiful picture of coral reefs. And we talked about the open ocean. So we're done. So that's the end of chapter 4. And we'll talk about, I want you guys to do all of the FRQs on page 116, 1 and 2, and then do the multiple choice on page 115 to 116. So do a multiple choice 1 through 11, and I'll tell you when it's due. So do the multiple choice on page 115 to 116, and do the 2 FRQs on page 116. Thanks, guys. I'll talk to you soon.